Good day, Algebra. We are continuing our talk about an arithmetic sequence. And just to recap yesterday, we went through a table. We talked about how an arithmetic sequence could be helpful because rather than continuing this table all the way out to 38 seconds, we looked for a rule. We found the rule. We used that to predict what the distance will be after 38 seconds. But an easier way, arguably, is using what's called an arithmetic sequence. So what was the definition that we wrote down for arithmetic sequence yesterday? Maddie? Yes. Finn? You with us? A pattern with constant addition, and I don't remember if I added this yesterday, but I want to put or subtraction because you can add negative numbers, which is the same thing as subtracting, but basically it's that constant pattern with addition or subtraction. And what was important about that word constant? What did we talk about there? Like that word constant, what does it mean for the pattern? Nathan?
Like in the table, like you're always adding.
You're adding the same thing, okay? A pattern with addition, such as +1, +2, +3, +4, that is a pattern with addition, but it's not constant, okay? So in the table, remember, we added 32, the same thing, over and over and over again. That's what we mean by constant addition or subtraction. And here is the formula for an arithmetic sequence. So what we're going to do is we're going to kind of define what each variable represents, and then what that value was in the context of our question. Because if you remember, our rule, okay, was 32 times t minus 1 plus 16. You should have that at the top of your page. Okay, so an is the answer. It's what you're looking for, right? What you're solving for. We'll put it like that. Okay, it's the answer or it's what we are solving for. So in the context of our 38 seconds, our answer was what? 1200, right? So in the above situation where we used the rule, our answer, what we were solving for, was 1200. That's why an is by itself on one side of the equal sign, okay? Because it's what we want to use this to find out, right? A1 represents the first term in the sequence. The first term in the sequence. Where'd you find it? Oh. Why?
Mr. Cleaner is so scary.
Oh, yeah. So A1 represents the first term in the sequence. What was the first term in the sequence in that table? Sorry?
Is it the t time?
Well, in the table up above, right, we had 1 second, 16, 2 seconds, 48, 3 seconds, whatever it was, 72, whatever it was. What was the first term in that sequence? In that pattern of adding 32, what came first, Colin? 16, okay? 16. So you can almost, our time increased by 1, and then the value of the distance, you can kind of, this is going to mess up my ink here when I scroll up, but we'll just deal with it here. Woo! Didn't mean to do that. We'll put that right back there where it was, okay? Go over here. This sequence, because it is a pattern of repeated addition, right? We're adding 32 over and over again. This x value or the t value, the time, you can kind of correlate this to where the first term is 16, the second term in the sequence is 48, third term is 80, fourth term is 112, fifth term was 144, et cetera, all the way out to the 38th term, which we found to be 1200. Right? So this increasing by 1 is important because that gives us the number of the term in the sequence, okay? Which is where we are heading next. The end, that works there. The end variable is the number of the term in the sequence you want to find. Okay? The number of the term in the sequence that you want to find. Very similar to our AN that we have here, and that's not an accident, right? This n value here and this n value here will be the same thing. Okay? Because that's what we're looking for, that number of the term. In our example up above, we were looking for the 38th term in the sequence. Okay? The 38th term in the sequence. We want to know the distance after 38 seconds. Yes?
What's the word before term?
The. Yeah. It was once said that my alphabet has like 250 letters in it because I combine THE to look like that. That's my THE letter. And then what else? Oh, my AN letter. Kind of connect that there. NU, ER is right there. TER, I connect all those. TER. So you have to kind of learn my alphabet for success in the class. Yeah. And then the D variable, it's what the pattern is. Okay? It's what the pattern is. What's being added, what's being subtracted over and over again. So in our example up above, the pattern of adding 32, that is the D variable in the arithmetic sequence. Okay? So how this would look, if we're looking for the 38th term, we'd say A38, right? Because remember that N in AN, that's our answer, but it tells us what number of the term that we want. A38 is equal to our first term, A1, which was 16, plus, in parentheses, N minus 1, N being 38. Again, notice that 38 and that 38, those two N's are the same. They're both 38. And then our pattern was 32. And if you'll notice, the formula that we came up with looks very similar to this. It's kind of in a different order, but it's got all the right pieces. We came up with 32 times t minus 1 plus 16. Those two formulas are exactly the same. We're taking 38 minus 1, multiplying by 32, and then adding 16 onto that. And so if you put this in your calculator, everyone do it now, so you make sure you can correctly, because it's a real bummer to get the formula right, but then enter it into your calculator wrong. Put that in your calculator. Spoiler alert, you're going to get, if you do it right, 1,200. Okay? If you get 1,200, you know you've done it correctly. If you don't get 1,200, look for an order of operations mistakes, parentheses mistakes. Yeah. It's going to cost you. Yeah? Okay. It's 16 plus, then in parentheses, 38 minus 1 times 32. Anyone having trouble getting 1,200? Okay. Everyone good? Okay. If you don't have a calculator, make sure you bring one for Friday. You are able to use a calculator on the test, and it'd be a real bummer to have to do, even though you could, math like this, pencil and paper, and just take up that time when you could use a calculator. So, all right, questions on the arithmetic sequence. Basically, a way to take a pattern and extend it. Okay, take a pattern and extend it. You could use this on your pattern block questions on your math packets if the pattern is constant addition or subtraction. Okay. Let's practice a little bit here. It says, write an arithmetic sequence of at least 4 terms using the given first term and the common difference. So we're kind of building to the full formula here. A1, remember that's your first term. The D variable is that common difference or that constant pattern. Okay, so what this is asking you to do is starting with 17 and a constant different or common difference of 6, what would come next in this pattern? It is going to be addition because 6 is positive there. Common difference just means how far apart something is. If something has a common difference of positive 6, you're right, the word difference does mean subtract, but in this case, just how far apart they are. A positive value would mean that we're increasing. So what would come next, Maddie? 23, and then 29, and then 35. Okay, just kind of getting you used to what that A1 means. It's where the sequence begins, and then what that D means, that pattern, that common difference, how the sequence is going to extend. Next one, A1 of -4, D of -3. We're starting at -4. And what would the next term in this sequence be? Fultinsky? -7. This time we're subtracting 3, right? A negative common difference we're subtracting. So -7, and then, anybody? -10, and then -13. Okay. Do the next one on your own. A1 of 5 and D of -11. A1 of 5 and D of -11. I'll get you started. It's a 5. Now what? You're welcome. Edward. -6, and then -17, and then -28. Okay. Next page. Now we build on it a little bit. Next set of directions say, use the given information to find the end term of the sequence. Put the values into the formula to solve. So first of all, the formula, right? AN equals A1 plus N minus 1 times D. I'm giving you all 3 pieces now. And you're just using the formula to find whatever term of the sequence that we want. So what this says is that starting at 6 and with a pattern of adding 4, find the 12th term in the sequence. Okay? Starting with 6 and a pattern of adding 4, find the 12th term in the sequence. So 6 goes in for A1, 12 goes in for N, and 4 goes in for D. And this is what we get. What do you come up with? Paul? 50. Can anyone at this point explain why the formula works? It just does. Isn't that nice when you just don't have to, you just trust everything? It just does. Okay? That's going to be the challenge by the end of this section here. Understand why the formula does what it does, why the formula works. Okay, let's take a look at the next one. A1 of 4, so starting at 4. This time the pattern is subtracting 3, and we want the 80th term in the sequence. Think about how nice this is. Rather than taking 4 and, -3 equals, -3 equals 80 times to get down to the number we actually want, we can just use this formula instead. Starting with 4, we want the 80th term in the sequence. So 80 minus 1. Okay? And the pattern is subtracting 3. Notice my use of parentheses around that -3 to show that we're multiplying by -3. Folks using a calculator, common mistake is they'll put just a -3 after this. So it'll take 80 minus 1, 79, and then subtract 3 from that. And obviously it's not what you want to do here. So make sure you are using your calculator correctly. You want to multiply by a -3. That negative sign is a different button than the subtraction sign. Okay, it's down below the 0. We're right around the 0 somewhere. What do we come up with? If you got an error, you probably use a subtraction sign here instead of a negative sign. Okay, the negative sign looks like this. The subtraction sign is longer. So make sure you've got the short one. Again, it's right down by the decimal point or something like that. What do you come up with? Katie, do you have a second on that? Negative 233? What? No? Okay. Why does that work? Why does the formula work? Colin? It just does. How nice to have just faith in everything you see in here. Maddie? Yeah.
For the one before that, I put it in my calculator 5 times and still keep getting 58.
58, huh? And you're putting this in exactly as you see it here?
Oh, there we go. Okay. I think I might have been.
Okay. Do the last one on your own. Plug the pieces in the right spot. You're starting at negative 50. The pattern of adding 71, you want the 101st term in the sequence. Take a look at the formula. Put everything in the correct spot. That's what you should have. And what do you get? Briggs. 7,050. Do I have a second on that? Okay. If you didn't get 7,050, make sure you've got the numbers in the right spot. Okay. And then make sure you put in your calculator correctly. Anyone need me to take a look at what they have? Okay. Coming back to that question, why does the formula work? For all I know, for all you know, I just be making this up because I needed something to teach today and job security and whatever else. Okay. Think about this now, right? 12 minus 1 equals 11, right? So we're essentially taking 11 times 4, which is 44, and adding that to 6 to get to 50. Okay? So what this formula is saying here is that we want the 12th term in the sequence. That means we're going to be adding 4 11 times. Well, if you add 4 to something 11 times, you're really adding 44 to it, aren't you? Because 4 times 11 is 44. Why subtract 1, though? Why is it 11 times 4, not 12 times 4? If we want the 12th term, why do we multiply our pattern, our 4, by 11 and not by 12? Yeah. Exactly. We already have the first term. Okay? So the first term being 6, we need to add 4 11 more times to get to the 12th term. Okay, that's the rationale for the minus 1. How many times are we actually subtracting 3? If we want the 80th term, we already have the first one. We have to subtract 3 79 times, which is negative 3 times 79. Okay, so having the first term of negative 50, we want to add 71 100 times. We multiply 100 by 71. Okay, so yes, the formula works, but it's also important to understand why. Okay, also important to understand why. Questions on this? Okay, now you get to determine if each sequence is arithmetic. If it is, identify the values of A1, N, and D, and then find the nth term. So when it says find A12 of 15, 22, 29, 36, first of all, is this sequence arithmetic? Because you can only use an arithmetic sequence if it's arithmetic. Is it, and why? Caitlin. Yes, the pattern is constant addition of adding 7. So this one's good to go. We're looking for our first term. What's our first term of the sequence? Izzy? 15. That's where we start. What number term of the sequence do we want to find? 12. And we get that from right here. Remember that AN, what you're looking for? The N is going to be the same with what you plug into the formula. We want the 12th term of the sequence. That's what that A12 tells us. And then what is the common difference? What is the pattern? Is it going to be positive or -7. Positive, because we're adding 7. Okay? Now you're the exact same spot as you were up above, where you plugged those numbers into the formula and got the answer. Right? The next one, find the 101st term of 1,024, 1,000, 976, 952. Is it arithmetic? Why?
Because it goes down by 24.
Goes down by 24. So we already have this part of it. This time it's going to be a -24 because we are decreasing. Okay. Our first term, 1,024. The number of the term we want, 101. And that comes from this information right here. Find the 101st term of the arithmetic sequence. That's what the A stands for, arithmetic.
So we just have to find those three things and go to the next problem.
No, you have to actually do it then, which is the same thing you did in the above section, which is why we're not going to go over in too much detail because we already talked about it. We only have 5 minutes left anyway. Okay. That's this section. You're determining if it is arithmetic and then finding it. In the last section, we got some word problems to work with here. Says your bank account currently has $160 and you're considering this day 1. You begin adding $8 every day. How much money will be in the account on day 50? Now, even if you did not study arithmetic sequences, what would you do here to solve this? What would just kind of your math brain, your problem-solving math brain tell you to do, Nick?
Like you would multiply 8 by 50 and then you add whatever you get from that to 160.
Yeah, which is close to what the arithmetic sequence is, right? The only piece that we're missing here is that n minus 1, okay? Because let's label our values here. Our first term, if we're considering this day 1, our bank account currently has $160 in it. That's where we're starting. We want to know how much will be in the account on day 50. So that's the number of the term we're trying to find, term of the sequence. And our constant difference, our pattern, is we're adding $8 each day. Okay. Now, what Nick described there, multiplying 8 by 50 and adding it to 160, that would be what you would do if you're looking for it 50 days from today. So technically the 51st day, right? But if we want the 50th day, we have to include that n minus 1 piece to get, because we already have the first term, right? On the first day of school, you bring a jar of 1,243 jelly beans, and starting the next day, eat 11 each day. So the day you bring it is day 1. How many jelly beans will be left in the jar after the 31st day of school? Then to train for an upcoming marathon, you run 1.5 miles on the first day of training and increase that distance by 1/8 of a mile each day. How far will you run on day 30? Write your answer both in miles and in feet. And to help with your conversion, just keep in mind that there are 5,280 feet in a mile, if you didn't already know that. Okay? Questions on CO8? Lovely. Homework for tomorrow. Practice test tomorrow. We'll review, and then your test will be on Friday. You may use a calculator on the test, or at least part of it, not all of it, part of it. So bring one. Okay, we'll talk about tomorrow which ones you can and can't use one on. That's how I math, folks.